expected value and variance of a discrete random variable. So expected value is basically the expected value or expectation of a random variable is the theoretical mean of the random variable, and is written by an expectation of notation of expected value of x is equal to mu. This is the mu or the theoretical value, which is expected value of x is the for all x's x times probability of x. So we multiply all possible values of x with their probability of occurring, so it becomes a weighted average of the x. So we had looked at it as a for dice roll, you can get 1, 2, 3, 4, 5, 6, which each with a probability of 1 by 6, 1 by 6, 1 by 6, 1 by 6. So the expected value of x is going to be 1 by 6, 1 plus 2 plus 3 plus 4 plus 5 plus 6. That comes to be around 3.5. So that is the expected value of x. That if you throw a dice, what is the expected value that you are going to get? You can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6, each with a probability of 1 by 6. But what is the expected theoretical mean? Obviously we can't get a number 3.5, but that's the expected value of a die roll. Now variance of x, going by the standard formula, is going to be expected value of x minus mu square, and this you can solve by algebra as expected value of x square minus expected value of x square. So that is a very important formula for variance of a discrete random variable, which we will come across many times. Now let's do a question on this. So suppose a coin has a probability, it's not a fair coin, so it has a probability of 0.6 of coming up head, and x represents the number of head when this coin is flipped. X is equal to the number of heads, which is the success, so it's a Bernoulli equation, when this coin is flipped twice. So probability of distribution of x, so you can get 0, 1 or 2, and p of x so what is the probability of getting a 0 head, that is getting 2 tails, which is going to be 0.4 times 0.4. One head is going to be 0.6 times 0.4, and 2 heads is going to be 0.6 times 0.6. So this is going to be 0.16, and this is going to be 0.20, and this is going to be 0.36. Expected value of x is going to be 0 times 0.16 plus 1 times this is actually going to be, how many ways we can get it? We can get it in 2 ways. You can get a head and a tail, and you can get a tail and a head. So 6, 4, 24, but that you can get it twice, so this will be the probability of x. This is actually 48, and this is also an important reminder that you can always add up these probabilities, and they need to add up to 1. If it's not adding up to 1, then you're doing something wrong. So So 0.6 times 1 plus 0.48 plus 0.36 times 2, that will come out to be 1.2. So that is the expected value of x. But now we want to find the variance. For variance, the formula is expected value of x square minus expected value of x whole square. So we want to find the expected value of x square. This is going to be the same 0 square times 0.16 plus 1 square times 0.48 plus 2 square times 0.36. So that is going to be 1.92. And using our formula for variance, expected value of x square is 1.92, and we know the expected value of x is 1.2. So you square it, and that you will give a number of 0.48. So this is much easier to calculate using this formula for variance of a random variable.